Welcome to Civil Engineering Edge. Today, we journey beneath our cities far below the traffic, skyscrapers, and daily chaos to explore the hidden world of tunnel boring machines, or TBMs. These colossal engineering marvels carve out the lifelines of modern cities without us even noticing. From subway tunnels to utility passages, TBMs are transforming how we connect, build, and expand. Get ready to uncover how these underground giants silently shape the future of urban living. Let's dive deep. Urban lifelines unseen. Imagine a bustling city, cars rushing, trains screeching, and skyscrapers piercing the sky. Now picture something far quieter, deeper, and almost invisible, the tunnels running beneath it all. These are the veins of the modern metropolis, and without them, our cities would grind to a halt. But here's the big question. How do cities expand underground without causing chaos above? The answer lies in an unsung hero: tunnel boring machines. Unlike traditional digging, which can rip apart streets and disrupt lives, TBMs allow engineers to construct massive underground passageways while the city above keeps moving. Think of them as urban surgeons, working silently and precisely, performing complex operations out of sight, and the scale is mind-boggling. We're talking about carving pathways large enough to carry trains, cars, and utilities, yet doing it without disturbing the foundations of skyscrapers or the flow of traffic. Every inch must be carefully planned, mapped, and executed with astonishing accuracy. TBMs combine brute force with delicate precision. Their mission isn't just to cut through rock. It's to create a safe, stable, perfectly aligned tunnel that can stand for a century or more. So next time you step into a metro or drive through an underground tunnel, remember you're traveling through an invisible lifeline carved by one of humanity's most extraordinary machines, giants of the deep. Enter the tunnel boring machine, not just a drill, but a moving city underground. Stretching up to 100 meters long, with cutterheads the size of a house, TBMs are essentially mobile factories. At the very front lies the cutterhead, a rotating steel face armed with discs and teeth that grind through rock and soil. Behind it, the shield protects workers and maintains stability as the machine advances. The erector follows, lining the tunnel with precast concrete segments that instantly create a permanent structure. Finally, the trailing gear houses conveyor systems, electrical equipment, and support cabins, making the TBM a self-contained ecosystem. But here's where it gets fascinating. Not all TBMs are the same. Some are designed for hard rock, chewing relentlessly through granite. Others, called earth pressure balance machines, handle soft soil and clay, carefully managing pressure to avoid collapses. Still others, like slurry TBMs, use fluid to stabilize loose ground. These giants don't just drill, they adapt. Depending on the geology, whether sand, clay, limestone, or volcanic rock, the machine's design is tailored to meet the challenge. Standing before a TBM, one can't help but marvel at its dual personality, half brute force, half delicate engineering. It's a reminder that creating tunnels isn't about digging blindly, but about designing machines as unique as the ground they conquer. The art of subterranean surgery. Digging tunnels isn't brute force, it's precision surgery beneath a living city. But how do TBMs maintain such pinpoint accuracy when working miles underground? The answer lies in guidance systems. TBMs use laser guidance, GPS, and high-tech surveying tools to stay perfectly aligned. Even a small deviation could cause catastrophic misalignments, so engineers monitor progress constantly, adjusting the cutterhead's orientation with millimeter accuracy. Then comes the challenge of managing the spoil, the millions of tons of material excavated. Conveyor belts inside the TBM carry rock and soil backward, loading it onto muck trains or conveyor systems that transport it out of the tunnel. Imagine an underground highway constantly moving earth while the machine pushes forward. Safety, of course, is paramount. Deep underground, risks multiply. unstable ground, high water pressure, and limited air circulation. That's why TBMs come equipped with advanced ground stabilization systems, ventilation fans, and reinforced safety protocols. Workers inside follow strict schedules, and emergency exits are built along the route to ensure preparedness. Each tunnel is not just carved but nurtured into existence, with every detail from alignment to spoil removal handled with surgical precision. In many ways, a TBM is less like a machine and more like a living organism, breathing, moving, and adapting to survive underground. This is the art of tunneling, controlled, meticulous, and utterly fascinating. Beyond transportation, shaping tomorrow. When most people think of tunnels, they think of subways or highways. But TBMs do far more. They're used to build utility tunnels carrying electricity, water, and telecommunications. They carve out massive sewer and wastewater systems, ensuring cleaner cities and sustainable living. Even underground power lines and high-speed data cables rely on tunnels created by these giants. Take London's Crossrail project, where TBMs carved 40 kilometers of tunnels beneath one of the world's busiest cities. Or Los Angeles metro expansion, where TBMs weave through dense urban neighborhoods, all while the surface life goes on uninterrupted. In India, China, and the Middle East, TBMs are at the heart of creating new megacities, and the future, it's even more exciting. Engineers are exploring robotic tunneling systems that could operate with minimal human presence. Artificial intelligence is being tested to enhance guidance, predicting soil behavior in real time. There's also a push towards sustainable tunneling, reusing excavated material for construction, and reducing environmental footprints. TBMs aren't just machines, they're city-shaping tools carving the foundation of tomorrow's urban landscape. The subways, sewers, and smart city utilities of the future will all be born underground, thanks to these extraordinary mechanical titans, the hidden architects of our world. As cities grow, their lifelines expand invisibly below the surface. TBMs are the hidden architects, building the arteries that carry people, power, water, and data without us ever noticing. They allow urban centers to grow sustainably, minimizing disruption and maximizing efficiency. Without them, modern megacities would collapse under their own weight, unable to keep up with the demands of millions. Think about it. Every smooth metro ride, every clean water system, every underground power line is a testament to TBMs and the engineers who command them. They're not just digging tunnels, they're sculpting the future. So the next time you walk the streets of your city, pause and consider what lies beneath your feet. Beneath the noise and chaos, miles of tunnels quietly hum with life, holding the very systems that keep modern civilization moving. These machines, silent and unseen, are monuments of human ingenuity. They represent the boldness to dig into the unknown, the precision to do it safely, and the vision to build for generations yet to come. TBMs truly are the subterranean city connectors, the hidden architects of our modern world. And that's the incredible world of tunnel boring machines, giants working silently below our cities, shaping the future of transportation, utilities, and urban life. If you enjoyed this deep dive, don't forget to like, share, and subscribe to Civil Engineering Edge for more stories about the engineering marvels shaping our world. Drop your thoughts in the comments. Would you dare to work inside a TBM? Until next time, keep looking deeper. You never know what wonders lie beneath.